know that it's been a long day and you've had a lot of material to soak in, and I thought you would like something light. So I decided that cryptography was really the perfect way to end a famously light topic, if ever there was one. So as Daniel said, I'm Cory. I work on open source Swift libraries at Apple, foundational, server-side Swift libraries, and I'm not going to talk about that today. I'm going to talk about a different passion of mine and an interest of mine, which is cryptography. And the reason I want to talk about it is that fundamentally, cryptography is everywhere. This is a pretty recent development in software engineering. It used to be the case that you could at least hope that you wouldn't have to think about cryptography too much in your day-to-day development. You were reasonably confident there were very smart people somewhere far away from you who thought hard about cryptography, but you yourself didn't have to think about it, to plug it into things, or to worry about that in any kind of particular way. Unfortunately, this is not true today. Nowadays, you find it everywhere. And one of the most common places you find cryptography is in client-to-server communication, the kinds of things that we do all the time. You can find this in forms of transport layer security, the underlying protocol that encrypts the web, usually not something you yourself have to write directly. But you will find it in things like API tokens. JWTs are incredibly common. You'll find request signing schemes. Anyone who's used AWS will see that you need to frequently sign data bodies. You will see things like secure credential storage, answering the question, how do I store user passwords? How do I store API tokens? In a way that keeps them safe and secure. There are, of course, more esoteric use cases, things we touch less frequently, but are nonetheless incredibly important. There are things like distributed identity management, trying to spread across multiple machines notions of either user or service identity. There are things like schemes for delegating authority. If anyone has used OAuth, you're familiar with at least one scheme for delegating authority, but there are a number of others. Some of them have excellent names, things like macaroons, often food-related. It says something quite a lot about cryptographers, I think. And there is obviously everyone's favorite, secure messaging software, something that has become an increasingly major part of our lives and something that software developers touch more and more. Nowadays, your average software developer is more likely than ever to have to deploy some form of cryptography in their applications, even if it's something as small as hashing some data. This is regardless of their development environment. It's regardless of how you conceptualize yourself as a software developer. It's beyond things like back-end or front-end. Whichever end you think you operate on, you are likely to have to touch cryptography. For Swift, we've had a number of libraries to work with cryptography, but the one that has mattered the most for client developers recently is CryptoKit. And I'd like to talk about CryptoKit just a little bit. CryptoKit is a brand new Apple system library. It was introduced at WWDC 2019, which I hope many of you were at. This was in the session Cryptography on Your Apps. I've given you a nice citation there if you'd like to go watch this session. Its goal is to be a Swift-first cryptography library that provides expressive APIs for performing cryptographic operations securely and efficiently. The particular area of focus here is to provide high-level APIs which are resistant to misuse. And this notion of misuse is something I'm going to want to come back to later on in the session. CryptoKit takes advantage of many of the powerful abstractions of Swift, the kind of things that we've talked about in previous dotSwift conferences, things like value types, things like generics, and things like reference counting. This gives your code powerful tools that perform well and, most importantly, are easy to use and hard to misuse. It's got a lot of features, a lot of tools for letting you perform important cryptographic tasks. A number of hash functions. People love a good hash function. It's got all of the SHA-2 family of hashes, including some older and less secure ones. It provides HMACs for validating integrity of data. It provides a number of ciphers called AEAD ciphers, which are the gold standard way to encrypt data. They protect you against malicious data modification, and in the absence of anything else, are the kinds of things you should use in your apps. And it provides a full suite of implementations for asymmetric cryptography, everyone's favorite thing to try to deploy using elliptic curves. This includes full support for both key exchange and signing and verifying, using the major curves standardized by NIST and the extremely popular curve 25519. This is a suite of features that cover the most important use cases that people have today and provides a clean focus on primitives and APIs that are easy to use. So why is CryptoKit important? Why did I want to talk about misuse so much? The biggest risk when you are writing cryptographic code is that it is very, very difficult to tell the difference between code that is correctly executing the operation you liked and the code that is doing so in a way that is unsafe or failing to achieve its goal. I don't know about you, but when someone hands me a string of random bytes, I can't tell if they're encrypted or not. This is the nature of encryption. When it's working, it looks random. But looks random is not a very clear metric, and it's not a secure one. This happens because most cryptographic primitives have an extremely wide range of ways in which they can be configured, and they have a lot of configuration options. This leads to APIs that are extremely hard to use. They bombard you with questions that only an expert can be expected to have sensible answers to, and many experts do not have sensible answers to. Often, all you want to do is encrypt some data in a way that you can safely store it and retrieve it later, but you will get asked tricky questions like, what block cipher mode do you like? Is ECB cool? What about CBC? Difficult. Initialization vectors. What is one? How do I get one? What do I have to do with it? Padding. What is padding? Does it matter? Nothing in this API thus far has reminded you that you might need to authenticate your data, the most important thing for you to do here, and the thing that the API doesn't ask you a question about. This has led to a lot of papers being published pointing out the weaknesses in many cryptographic libraries with code that touches cryptography, often being called the most dangerous code in the world. Users are expected to be experts in order to use these libraries correctly, and if anyone in here has worked with some of the pre-existing low-level APIs, like OpenSSL, you may be familiar with what I mean. These difficult-to-use APIs have led to a number of vulnerabilities in all kinds of products in the software industry, and this is an unacceptable state of affairs for our industry to be in. As a result, there's an important school of modern cryptographic API design focusing on misuse-resistant APIs. The goal is to provide the user with a limited number of choices, all of which are secure, in a way that makes it very hard to achieve suboptimal outcomes from the API. If you ask for encryption, you should get the best possible version without being forced to make too many choices about what that might mean that could diminish the value of your result. CryptoKit is an important piece of this design work. It aims to provide these misuse-resistant APIs, but CryptoKit is an API that is only available on Apple platforms. And here's the thing. None of the problems I just outlined are specific to developers on Apple platforms. Unfriendly, difficult-to-use cryptographic APIs are rife on other platforms as well. It's important that our entire industry be working together to build better, safer cryptographic APIs to ensure that as much of our computing is as secure as possible. The reason is many applications that run on Apple platforms have components that run on other platforms. They have back-end servers or web app versions for other platforms. Often, these other components need to do similar work to the client applications. They're a critical part of the cryptography pipeline, and they must also handle the data correctly. To that end, I'm thrilled today to be able to announce our newest tool for helping developers navigate this subtle and important space, Swift Crypto. Thank you. Swift Crypto is a fully open source re-implementation of the CryptoKit APIs that is supported absolutely everywhere that Swift is. It is available right now, licensed permissively under the Apache 2 license, available for Swift 5.1 and later, using Swift Package Manager in a package that is semantically versioned. The package contains two major chunks of code. The first are the definitions of the public API of CryptoKit. These files are the original versions from CryptoKit itself and have been made open source as part of Swift Crypto. They are accompanied by a brand new implementation of those APIs that uses Google's boring SSL library. This means there are now two peer implementations of the CryptoKit APIs. The first, available on Apple's platforms, uses Apple's proprietary core crypto library, and the second, available everywhere else, uses boring SSL. We have implemented every single API in CryptoKit that does not rely on specialized hardware. That is, any API that we can expect to run on a reasonably wide range of hardware has been fully implemented. This is the overwhelming majority of the API surface of CryptoKit. Swift Crypto is available in the Swift package manager without any platform restriction. When you use it as a dependency on an Apple platform, it delegates to the system copy of CryptoKit, passing all API calls directly through. On any other platform, it will use the open source implementation instead. So what does this look like? Perhaps you want to encrypt some data with Swift Crypto. This is an extremely straightforward operation. You'll notice the encryption itself is only one single line of code. You'll also notice that there are no awkward questions here, like what nonce should you use, or what your data format look like. All these decisions are made for you. This kind of encryption is safe to use in almost all contexts. It's the kind of encryption you might want to use if you're storing data somewhere your app will decrypt later, or to send to another person that you have a pre-negotiated secret with. Perhaps instead you want to validate that some data you've stored somewhere was stored safely, or that it has been correctly and actually sent by the remote service you expect, and that it hasn't been tampered with. For that, you use something like a message authentication code. In this case, something like HMAC. CryptoKit gives you yet another one-liner for doing that, and Swift Crypto gives you the exact same one. HMAC is a vitally useful primitive that is used in a surprising number of places you might not expect, especially in client-to-server communication, where we get some great advantages out of having Swift Crypto. For example, you can find it in JWTs, macaroons, both technologies for authenticating in networked systems. And as a final code example, consider generating a shared secret using elliptic curve Diffie-Hellman. That is the most technical sentence I'm going to utter today. Those of you not familiar, this is a primitive that allows two individuals to share data publicly, but come up with a secret that only the two of them can possibly know. This is nothing short of mathematical magic. I highly recommend reading about it if it's the kind of thing that sounds interesting to you. The math is surprisingly straightforward. This is how you would generate such a shared secret in CryptoKit. Like the one I talked about earlier, you could use such a shared secret to generate a key for encryption purposes. And you can see that CryptoKit does this in just a few short lines of code. It's shorter than it looks if you don't try to make the text large enough to be read from the back. So, what parts of CryptoKit does Swift Crypto support? I said earlier what doesn't rely on specialized hardware, but to be more specific, essentially everything. The only rule is that if you see the words secure enclave, that API has not been implemented in Swift Crypto. It will continue to function only on Apple platforms that expose a secure enclave. The implementations in Swift Crypto are entirely compatible with the ones in CryptoKit. We share the same test suites. We can test the two implementations against each other. Everything we do is also done by CryptoKit. One of the other important areas of focus for us in this work, other than making sure these two libraries were perfectly compatible together, was to make sure that we could evolve Swift Crypto going forward. With open source projects, it's extremely important that the community is able to guide the evolution of the project and to propose new APIs to that project, as well as to fix bugs and improve the infrastructure around the project they use. So I'd like to spend the remaining time talking a little bit about what our plans are for evolving this project. The core API of Swift Crypto, everything that is immediately available, will remain in sync with CryptoKit's API as it stands on the latest releases on Apple platforms on which CryptoKit is supported. That means whenever a new API is added to CryptoKit, we will be adding it to Swift Crypto as well, except where that API relies on specialized hardware. Of course, that covers the case where we at Apple would like to add new APIs, but as I said earlier, it's important the community must be able to propose ideas for new APIs as well. We are defining a process for adding new core API. This is API that will eventually become a fully fledged API in both CryptoKit and Swift Crypto. This will allow the wider community to propose new APIs that will eventually make their way onto Apple platforms. This has an extraordinarily high bar to entry, both in terms of the quality of the API being proposed and the importance of the feature that is being added. It is very important that these features will be widely used and have vital client-side uses. Features like this will follow OS release cycles. We will not be releasing new API in the Swift Crypto main namespace until such an API ships in CryptoKit as well. And I want to stress something important here. Both Swift Crypto and CryptoKit do not intend to support every cryptographic primitive in the world. Shipping new API in CryptoKit implies a substantial support burden, as it does on Swift Crypto, and the threshold for wanting to take on that burden is very, very high. This means most attempts to add new API servers to Swift Crypto will be rejected, but not all, and the most important ones will be added. I also want to stress something about redundancy. In many cases, there is redundancy in cryptographic primitives. There are many ways to encrypt data. There are many stream and block ciphers, most of which have strange names and you have never heard of. We do not intend to support every primitive that has ever been conceived, or even everything that you can find in the wild. Instead, we want to target the common useful core of the API surface. The goal is to focus on a safe, shared set of implementations. This is the goal. So, we're coming towards the end. How do you get involved with Swift Crypto? There are lots of ways. The source code is open source, available at our GitHub repository either now or shortly, depending on my colleagues in the United States. This repository is also where you can file issues. When you file issues, these issues should be focused to Swift Crypto. If you need to provide feedback about CryptoKit itself, please continue to use the feedback process that you use today. If you want to suggest new API, you can also do that on GitHub. We have a template for API proposals. Please read it, and please use it if you want to file new API proposals. If you want to provide an implementation of your new API proposal, please do so. As with all open source projects, and as we heard with Erica, as with Swift, all issues and suggestions for improvement are better if they have accompanying code. They are much more likely to be accepted. Otherwise, please use Swift Crypto. Please discuss it on the Swift forums. Reach out with feedback from using it. Tell us if you find limitations or if things are awkward or unhelpful. We would love to know what you're using it for, what limitations you find, and any of your other thoughts. We are very, very excited to see what you're going to do with this brand new library. If there's anything you'd like to chat about, please find me after the session on Twitter or the Swift forums. And on behalf of absolutely everybody involved with Swift Crypto, we are so pleased to be able to share our work with you today. Thank you very much.